isolating the variable and whatnot. The only new thing is that we just have more than one inequality sign to deal with, and the words and or appear. So we're just gonna have to see how we're going to deal with them, but it's really not that bad, so go ahead and get started. Alright, so let's go ahead and get into the first example here. I know we have a compound inequality because I'm dealing with more than one inequality sign. I'm just gonna isolate regularly and just isolate each one separately. So add 1, I would have to do the same thing here. So just might as well do that. These cancel out, we get 2x is less than 6. Divide by 2, we get that x is less than 3. And let's see what happens over here. So then we get 2x. So I get that x is less than 3 and x is greater than negative 1. So thinking about this logically, my solutions have, my answer has to satisfy both pieces because it's saying and. So let's go ahead and put this on a graph to get a better understanding of what's happening. Alrighty, so on the graph I went ahead and draw the parts that we're interested in. So we're talking about x values that are greater than negative 1 coming from that guy. So I've indicated that in red going to the right. And then we're looking at x values that are less than 3. So I indicated that in blue going to the left. And neither one is not included because we see no equal sign. And the region where this and is applying is where both of the colors overlap each other. Because notice this would just infinitely keep going to the right, the red, and the blue would go an infinite amount to the left. But notice there's an area where they overlap, right in here. So just graphically, this is the area we're talking about when we're talking about and. That's where our solutions lie. And that's why the and is implied, is because it's in between negative 1 and 3, all the points in between them. Okay, so I just wanted to point out that sometimes you see these compound inequalities written like this as a triple set type looking thing. So I just wanted to point out that this is just like the and case. So when you see it in a format like this, the and is already implied. So if we want, we could go ahead and write it out into 2 pieces like we saw earlier. So if I were to cover up this piece, it would be like negative 3 is less than 2x minus 1. And if I cover up this piece, we just get that. So it would be 2x minus 1 is less than 5. I just wanted to just show you that those two are equivalent, and it's more efficient to go about isolating it this way. It might not look so promising right now, but let's go ahead and look at that, and it's a more efficient way rather than splitting it up and solving. So going about isolation this way, in either case you have to add the 1 over in either case, right? So now we just have to do that to all 3 sides. Okay, and the only thing left to do now is divide the 2, and we just go ahead and do that to all 3 sides. So this is the same solution that we got from the first example I did, because this is the first example I did, it's just in that triple set format. And this is nice because we don't have to look at the whole overlapping situation. This is just letting me know that my solutions are stuck in between negative 1 and 3. So let's go ahead and put this into set notation and interval notation. So right here, as far as the set, I'm going to open up a brace. The variable we're talking about is x, such that this holds, that this is true. And we just close that off. So set notation is the same. And then interval notation, I sketched out the graph earlier, but this is just letting me know the values are just in between negative 1 and 3. neither of them are included because there's no equal sign, so we're just going to use parens for those. We start at -1 and we end at 3. Okay, so here's the second example. Notice I could just go ahead and split this up again because I know the and is implied here, but trust me, it's better to isolate it when it's in this triple format where it's more efficient. So in either case, if you were to split it up, you'd notice that you'd have to subtract the 1 first. So let's just subtract 1 on all 3 sides. Okay, and the only thing left to do is to divide by 3. Okay, and we just saw this case. It's letting me know that our solutions are in between -2 and 1, and both of them not being included. So let's go ahead and write it in set notation, interval notation, and graphic. Alrighty, so we got that to be our solutions. So let's go ahead and put it to set notation first. So set notation, we're going to use the braces. The variable we're talking about is x, such that what we got is, what follows after this is true. So then we close the brace off just like before in the inequality videos. Now in interval notation, let's go ahead and graph it first. So there's no equal sign, so I'm not going to include either of them. So let's see, -2, be an open circle, and 1 will be an open circle. Now if we cover up this piece, it's saying that x is values that are bigger than -2, greater than. So I'm going to shade this way. And then if I cover up that piece, this guy is letting me know that x is less than 1. So values that are less than 1 would go this way. And then we notice that the and is implying to the section where these guys overlap each other, which is right here. Okay, so now if we were to put it into interval notation, and you could use parens here if you'd like also, I'm just going with the open hollow circles today. So, interval notation. So, remember we're trying to describe to someone what's happening from left to right. So coming in from the left, there's no activity happening. The only activity is where the colors interlap each other. So we hit -2, and then we stop at 1, and neither of them are included. So let's just try some more examples. Okay, so third example, I forgot to include this guy. Okay, and it doesn't matter that one is included and the other one's not. We're just going to isolate regularly. And again, when it's written in a triple form like this, the and is already implied, so I could split this up into 2, but that's really not efficient in my opinion. So let's go ahead and isolate this regularly, subtracting 5 on both sides. Okay, so now the only thing we have to do is divide by -2 on all 3 sides. Remember from just basic inequalities, when you divide or multiply by negative in the process of isolation, the signs have to flip. So both of these inequalities have to flip right now. So this guy will flip, and this guy will flip. Alright, but we've never, this is fine, it just tends to, we're not really used to seeing it this way. So we could just flip this back around so the arrows are pointing in a natural direction where, I'm more comfortable seeing it that way also. So I'm just going to go ahead and flip our arrows around again. So x, we're talking about this piece, is saying x is greater than. So x is greater than -6, and this part is saying x is less than 4. Oh, sorry, this guy got that. I think the explanation, there's really not a good explanation to it. Just really flip it around where the -6 flipped and came here and just carried its inequality with it. And then the 4 came back this way and carried its inequality with it. Shouldn't think about that too much. Okay, so now let's go ahead and put into set, interval notation, and graphic. Alrighty, so we got our solution to be that. Let's put into set notation first. So we got a brace talking about the x such that this is true, or this follows. Alright, getting set notation out the way is great. Don't have to think about it too much. Interval notation, let's sketch it first, because sometimes it's better to look at the graph to come up with interval notation. So -6 is not included. Notice I've scaled by 2's. So this -6 is not included. And this 4 here is included. And we've seen this case like twice. This is just saying x is in between them. So the red's going to go to the right and the left is going to go to the blue, but we're really interested in the part where they overlap each other, because this is the AND case. So I'm just going to go ahead and just shade that part, which is right here. Okay, now that we have a sketch of this thing, interval notation might be easier. You don't have to do this if it doesn't help. So again, going from left to right, I want to describe to you what's happening here. So coming from the left, the first thing I hit is -6. I know it's not included. Let's see what happens next. So we get all these are good. And then we hit 4. And 4 is included this time, so we use a bracket.